Hi, I'm Yash. I tutor AP Calculus BC and all other math subjects beneath that particular level, AP Macro and Microeconomics, AP Statistics, AP Physics C, as well as Honors Physics, AP English Language, AP US Government, AP World History, and Honors Chemistry. Tutoring is a real passion of mine, and I've been tutoring for all 4 years of my high school career at the HKIS Math and Science Center, as well as the HKIS Humanities Center. I also tutor privately for a number of students at other international schools in Hong Kong. Tutoring is something I really enjoy, and I hope to continue tutoring throughout the 4 years that I'll be at college in Harvard University, where I'll be majoring either in economics or in applied mathematics. Hi, I'll be teaching U substitution in Calculus BC. U substitution is useful when you're trying to solve integrals for which the common methods of integration are not applicable. So U substitution is particularly useful, for example, when you're integrating something that is separate from just a single variable, perhaps when they're a variable which is multiplied by itself. So let me give you an example of something, of an instance in which you may have to use U substitution. So for example, the integral 2x times the root of 1 plus x squared. Right, so this particular integral. My apologies for the handwriting here. Dx. Now I'll just quickly note here that it's very important that whenever you set up an integral, you mention the you remember to write the dx at the end. That's something a lot of people forget, but strictly speaking, if you do forget this, you're liable to lose points on the AP, as this is a part of every integral expression that you write. So with this particular integral, finding the antiderivative is not something particularly straightforward. A straightforward example of finding an antiderivative would be, for example, the integral x squared dx, right? So we all know, if you've done introductory calculus BC, that the integral of x squared dx would be 1 over 3 x cubed plus c. And of course, the plus c is very necessary as it signifies the integration constant, which you must have in every integrand's answer. So in this particular instance, right, with the integration of x squared dx, the answer is pretty straightforward because, of course, if you take the derivative of that answer, 1 over 3 x cubed, you end up with x squared, which is, of course, the fundamental theorem of calculus, right? The derivative of an integral is that particular integrand, x squared in this case. But we see that with 2x times the square root of 1 plus x squared, this particular method that I just showed you doesn't work so well. So what do you do with 2x multiplied by 1 plus x squared? You have to do something called U substitution. With U substitution, you use a variable, typically the variable u, thus the name U substitution, and substitute it in place of one of the expressions within this particular integrand. So in this particular case, we might use u equals 1 plus x squared, okay? So if we use u equals 1 plus x squared, let me just quickly erase this. We're going to use u equals 1 plus x squared as the substitution in this particular instance. Now, the first thing you do is when you use u equals 1 plus x squared, you also have to figure out what du is. In other words, the derivative of that u. So let's write down u equals 1 plus x squared. U equals 1 plus x squared. All right, you need to find what du equals, right? Because the objective of U substitution is to essentially substitute in that du for your dx, because dx is the derivative of x, and now because you're substituting a u, you want to find the derivative of u, so you can solve this particular integration question. So du, all right, so du equals 2x, right? Because of course, when you take the derivative of a constant, 1, you get 0. And when you take the derivative of x squared, you get 2x. And again, remember, it's du equals 2x dx, right? Because when you take the derivative of x squared, you have to remember that that derivative includes dx, because it's in relation to the variable x, not the variable u. So now that we have du equals 2x dx, what can we do? So we want to get rid of the dx from this particular integrand. And to get rid of this dx, we can substitute in, thus use substitution, substitute in this particular expression, du equals 2x dx, right? What this means is that dx equals du over 2x. Dx equals du over 2x. So when we substitute this in, right, this key expression here, dx equals du over 2x, into dx, what do we get? We get this, 2x multiplied by the square, you get 2x multiplied by the square root of u, right? Because remember, we substituted in u for 1 plus x squared, so we get the square root of u multiplied by du over 2x. So what do you see here, right? Clearly, you can eliminate these two x's, right? Because you've got 2x divided by 2x, you can get rid of this particular expression from your equation. So what you're left with then is the integrand of root u du. Now, as you would be able to tell, we know how to integrate the square root of u, right? This is a pretty standard integration procedure, right? The square root of u is simply 2/3 of u to the power of 3 over 2. Right, so this then equals this plus c. Now it's important that you don't write this down as your answer to the u substitution question, because of course it's not, right? Our question is, what is the integrand of, what is the integral of 2x multiplied by the square root of 1 plus x squared? And right now all we've got is 2 over 3 multiplied by u taken to the power of 3 over 2, which is not a satisfactory answer. What we do to finish this question and how we arrive at the final answer is to then reverse that substitution, right? So we've already established that u equals 1 plus x squared. Now we need to substitute in that 1 plus x squared for u to find the final answer to this particular problem. So when we substitute in 1 plus x squared for u, we get the answer 2 over 3 1 plus x squared to the power of 3 over 2 plus c. And that's the answer to this particular integration question. Of course, it's important to make sure that you've got this answer correct. It's important to check your answer. And how do we do this? Well, by the fundamental theorem of calculus, if we take the derivative of our particular answer over here, which I'll just draw a box around right now, if we take the derivative of this answer, we should end up with 2x multiplied by the square root of 1 plus x squared. And of course, if we take the derivative of this expression using the power rule, 3 over 2 multiplied by 2 over 3 equals 1. And then we get that square root because we subtract 1 using the power rule. Then we take that chain rule, and of course we end up with 2x multiplied by the square root of 1 plus x squared. I won't write that out for you because if you had reached this particular level of u substitution, that chain rule would have been evident to you. But of course you have to ensure that you do take the chain rule to check your answers whenever you solve an integrand like this. I hope that was clear to you. Thank you for listening to my little mini lesson there. And I hope to see you soon. I look forward to tutoring you in whatever subject it may be.